All right, welcome back everyone to the deep dive. We like to get into the nitty gritty and really dissect some of the most fascinating developments in AI. And today we're diving into something that I think a lot of you are really going to find interesting. We're going to be taking a closer look at how we interact with OpenAI's powerful models. Now, I know many of you out there are already familiar with the chat completions API. I mean, it's been a game changer, hasn't it? But there's a new kid on the block, a newer approach called the responses API. And that's what we're here to unpack today. So what we really want to do is, well, figure out what makes this responses API different. What sets it apart from the chat completions API that we all know and in many cases love. And even more importantly, I think we want to understand what advantages this new approach might offer, especially for those of you out there who are thinking about building, more advanced applications, the kind of applications that can really do things in the world.
Yeah, that's exactly it. We've been spending some time, really poring over the latest documentation that OpenAI has released. And we've been comparing these two approaches side by side to try and distill the key insights for you. And, one thing that immediately jumped out at us is this concept of the responses API as a more, as they put it, agentic API primitive. And this is sort of it might sound like jargon, but that's a really important idea. Think of it this way. The responses API is designed to be a fundamental building block for AI systems that can take action, that can do things in the world, not just, process language and generate text. And a core part of that is this idea of built-in tools.
Built-in tools. So it's not just about talking or having a conversation anymore.
Yeah, exactly. It's about going beyond just the conversation. So built-in tools, these are ready-to-use functionalities that your AI can leverage directly. And they come baked right into the responses API. We're talking about things like, there's web search, which allows your model to actually go out and access information from the internet in real time. There's file search, so it can analyze documents that you provide. And then there's this really intriguing one called computer use, which I think really pushes the boundaries of what we traditionally think of as AI capabilities. And we're going to spend a good chunk of time really unpacking that one later. And, on the horizon, we're even seeing hints of things like audio processing and even a code interpreter being integrated directly into the responses API.
Wow. So this sounds like, a really significant evolution, even almost like a paradigm shift in how we think about interacting with these models. So for our listeners out there, maybe some who are already using chat completions, maybe some who are just starting to explore OpenAI's APIs, how should they start to think about building applications in light of this new responses API?
The core shift is this idea that the responses API is really architected from the ground up for building applications that take action to achieve some kind of a goal. And it really streamlines what can often be very complex processes involved in using external tools, running code, and really managing the flow of information when you have these multi-step tasks. All these are crucial elements when you're thinking about building effective AI agents.
Okay, so agents, that's a term we hear a lot. And it sounds like this responses API is really geared towards building those kinds of systems. But what about the good old chat completions API? Where does it fit into this new landscape?
Yeah, chat completions isn't going away anytime soon. In fact, OpenAI's own documentation, they describe it as kind of an industry standard for building AI applications. And it makes sense. It really excels at that core task of generating text, whether it's for, creative content, summaries, engaging in these conversational interactions. It's been the foundation for so many applications out there. And it's important to remember that OpenAI is committed to continuing to support and develop the chat completions API. So, if you're out there and you're heavily invested in chat completions, don't worry. It's not going anywhere.
Okay, good to know. That's reassuring. So maybe a helpful way to think about it is responses API for applications that do things and chat completions for those that primarily generate content.
I think that's a really useful distinction. And to make that doing things capability really effective, that's where state management and events come into play. And this is where the responses API gets, pretty interesting, especially for those of you out there who are really into the technical side of things.
Okay, stateful API and semantic events, those terms sound a bit, technical.
Yeah.
Can you break down why these are important for our listeners who are, trying to build real-world applications?
Yeah, absolutely. So the responses API, it's described as being stateful and having a predictable, event-driven architecture. Now, what that means is essentially this. When your application interacts with the responses API, the API itself, it keeps track of the ongoing interaction, the ongoing task, in a much more structured way. And whenever something happens, right, let's say the model generates some new text or it uses one of those built-in tools we talked about, the API emits a very clear signal, we call it a semantic event, that tells you exactly what has changed. So for example, it might send an event that says, hey, new text output has been generated.
So instead of me, the developer, having to figure out, okay, what changed between these two responses, the API is actually telling me directly.
Precisely. And you can contrast that with how the chat completions API works. In a multi-turn conversation, for example, you essentially just get the new response appended to previous content. So if you want to figure out exactly what's new, you have to, as a developer, manually compare those, content fields between those two responses. So what the responses API does by giving you these very explicit events, it makes it so much easier to build integrations that react to very specific changes. It makes your code cleaner, especially when you're dealing with this really complex multi-step logic. And it also makes it more reliable because you have this more precise information about what exactly has changed.
Yeah, that makes a lot of sense. So if I'm building something that needs to keep track of a conversation or maybe a process that has multiple steps, it sounds like the responses API would just give me a much more, well, robust and manageable way to do that. Now, I noticed in the documentation that they actually provide some code examples, showing basic text generation using both of these APIs. So maybe it'd be helpful to actually take a look at that code and see these differences in action.
Yeah, I think that would be really illuminating. So let's take a look at the Python examples they provide. So with the chat completions API, right, the way you make a call is you use this client.chat.completions.create, right? And you give it a list of messages. And each message has a role. So, is it the user? Is it the assistant? And of course, it has the actual content. Now, with the responses API, the way you make a call, it's a bit different. You use client.responses.create. And instead of this big list of messages, you actually just provide an input. Now, this input can still be a simple string, but, if you want to do a direct comparison, you can actually provide an array of these same role-based content objects. So, very similar to what you might be used to with the chat completions API.
Okay, so at least, initially the way that we send information to the API looks pretty similar. So where do we start to see those real differences emerge?
The really key difference, I think, it comes in the response that you get back. So with chat completions, what you get back is this choices array. And then within that, you'll find a message object, and that message object will contain the content, which is the text that the model has generated. But with the responses API, you actually get back a typed response object. And that response object, it has its own unique identifier in id, which can be really useful for tracking. And the actual output, it's nested within a content array. And in there, you might find an object that has a type of output text, and then that will contain the actual text. So, in a nutshell, the responses API gives you a much more structured, much more explicitly typed response compared to the chat completions API, which kind of gives you a more general output. And what this means, practically speaking, is that it's so much easier to access the main result in your code. It makes the code cleaner. It makes it easier to work with.
Yeah, it sounds like a much more sort of organized way of getting that information back. And the docs actually mention a bunch of other structural differences as well, so maybe we can touch on a few of those quickly.
Yeah, absolutely. So, we just saw one, right? Instead of that choices array, you get this more straightforward output field in the responses API. And then there are a few others. So for instance, if you're working with structured data, if you want to specify a particular format for the output, that mechanism has changed. So in chat completions, you would use this response format parameter, but in the responses API, you use this text.format parameter. So again, a slightly different way of doing things. And then function calling also has a bit of a different API structure, both in terms of how you define the functions that you want the model to use and how the results of those function calls are returned in the response. And even, some really small things like the parameter that's used to influence the model's reasoning effort. In chat completions, it's called reasoning effort, but in the responses API, it's called reasoning.effort. So, lots of little, maybe subtle changes there, but important to be aware of if you're migrating or, starting to build with a new API.
Right, right. A lot of these are, more granular changes in just how the API itself is structured. Now, earlier you mentioned how managing the state of a conversation is handled differently in the responses API. Can you elaborate on that a bit more?
Yeah, so in the chat completions API, if you want the model to remember previous turns in a conversation, you, the developer, are responsible for keeping track of the entire conversation history and then sending it along with every new request. So, it's kind of a manual process. But the responses API, it introduces this really helpful concept of a previous response aid. So what you can do is essentially tell the API, hey, this new request, it's actually a continuation of the response that has this particular ID. And then the API itself handles some of that state management for you. So for you as the developer, that means a lot less manual juggling of that conversation history in your code. And, that can be a real time saver, especially when you're building these longer, more complex interactions.
And lastly, I think it's worth mentioning that there's a little note in the documentation about how data is stored by default. Are there any key differences there between the two APIs?
So both of the APIs, by default, they do have storage enabled. So with responses, each response is stored by default. However, you can disable that on a per request basis. So if you want to say, hey, don't store this particular response, you can just add, store vals in your API call. And similarly for chat completions, at least for new accounts, those completions are stored by default. But again, you have the ability to say, hey, you know what? I don't want to store this. So yeah, the default is storage enabled, but you have control over it in both cases.
All right, so we've covered a lot of ground here, talking about the differences between these two APIs. So, for those developers who are already using these APIs, or maybe they're thinking about using them, what would you say are the key takeaways here? It sounds like if you're building something fairly straightforward, just basic text generation, or maybe a simple chatbot, the chat completions API is still a perfectly valid and powerful tool.
Absolutely. The documentation really emphasizes that. The Chat Completions API, it's their most widely adopted API, and they're going to continue to support it, with new models, with new features, especially when those advancements don't really require these built-in tools or, when you're not dealing with these really complex multi-step workflows. So yeah, if your application's core need is just that text generation, that simple conversation, you can absolutely stick with Chat Completions.
But if you need to go beyond that, if you need those more advanced, action-oriented capabilities, that's where the Responses API really shines.
Yeah, I think that's a great way to put it. The Responses API, it's really being positioned as the future direction for building, true AI agents on OpenAI. And what's interesting is that it actually incorporates a lot of valuable feedback that they got from the Assistance API beta. So, it's been designed to be even more flexible, faster, and easier for developers to integrate. And what they're actually planning to do is to achieve full feature parity between the Assistance API and the Responses API. So they're going to bring over features like, these assistant-like and thread-like objects, and even the code interpreter tool. So, it's not just a side project, it really is a strategic evolution.
So this is serious business. This is the Responses API. Now, what does this mean for the Assistance API, the existing one, in the long run?
So what they're saying is that once they achieve that full feature parity, the plan is to actually formally deprecate the Assistance API. And the current target for that is sometime in the first half of 2026. But of course, they're going to provide a very comprehensive migration guide to help developers transition their applications smoothly and, to ensure that they can preserve their data. And until that formal announcement comes out, they are going to continue to deliver new models to the Assistance API. So it gives developers, a good amount of time to plan and execute any necessary migrations.
Yeah, that's good. It gives people time to prepare. Now, let's get back to those built-in tools that you mentioned earlier that are part of the Responses API, the web search, the file search. Those sound incredibly powerful. I mean, it sounds like they really allow the model to access and utilize information that goes way beyond its initial training data. It can actually go out and find new information on the fly.
They are really powerful. I think they really do extend the model's capabilities significantly. So, take web search as an example. If you have web search enabled and you ask the model a question about something that happened, very recently, the model can actually use that web search tool to go out, retrieve the relevant information from the internet, and then incorporate that into its response. And the documentation, it actually includes some really clear code examples, in JavaScript and Python, showing how to enable that web search tool. And it's actually remarkably simple. You just include this little, snippet of JSON in your API request. It's just type web search preview within that tool's parameter.
So it's basically just a simple way of telling the API, hey, these are the tools that I want to make available to the model.
Exactly. You just list them in that tools array when you make your responses.create call. And the documentation, it actually goes on to list all of the currently available built-in tools. So we've talked about web search and file search. File search allows you to, take documents that you've uploaded and then search through those documents, for relevant context. And then there's that, really exciting computer use tool that we're going to get to in a minute. And then there's also, good old function calling, which allows the model to interact with your own custom code and external systems. And as we mentioned before, audio and the code interpreter, those are also on the roadmap. So you can imagine, building a research assistant, for example, where it could analyze your own notes and documents using file search, and then go out and pull in the latest findings from the web using web search, all within a single API call. That's pretty amazing.
Yeah, it's really starting to paint a picture of, how powerful these tools can be. But how does the model decide when it needs to use these tools? Do I, as the developer, need to explicitly tell it, hey, go use web search? Or is it a bit more, intuitive than that?
It is quite intuitive, actually. The model is actually designed to be pretty smart about it. Based on the prompt that you give it, it'll automatically try to assess whether using one of those configured plays would actually be helpful, to fulfill the request. So, for example, if you ask it, what's the weather like in London right now, and you have the web search tool enabled, it'll probably, go ahead and use that to get the latest information. But if you do need more precise control, you can always use the tool choice parameter in your request to explicitly tell the model, hey, I really want you to use this particular tool. Or you can even force it to use a specific tool. So it gives you a good balance between the model's own, reasoning capabilities and then your need for specific control in certain situations.
Okay, so it's very flexible in that sense. And you also mentioned that we can still define our own custom functions using that tools array. So it's not just limited to these built-in tools that OpenAI provides.
No, not at all. So alongside those built-in tools, you can still define and use your own custom functions. So this lets the model interact with your application-specific code, maybe access some proprietary data that you have, or even trigger certain workflows that are specific to your application. So it really becomes a very versatile platform, I think, for building all sorts of intelligent applications that are tailored to your specific needs.
All right, well, I think it's time to really dive into this computer use tool. This sounds like something truly, innovative. The idea that we can now have an AI model that can actually interact with a computer interface and even control it to some extent.
It really is, pushing the boundaries. So the documentation describes this computer use tool as an application of their computer using agent model. And it's available right now in preview as computer use preview. Yeah. And what it does is it combines the advanced reasoning capabilities of GPT-4o with these sophisticated vision capabilities to essentially simulate the way a human interacts with a computer interface to perform tasks. And, what's really important to highlight here is that this capability, it's only available through the Responses API. It's not part of the Chat Completions API. So, this is one of those features that really sets the Responses API apart.
Yeah, it sounds like it. It really is moving into a whole new realm of possibilities. Now, given that it is in beta, are there any particular, considerations or maybe limitations that we should be aware of as we start to experiment with this tool?
Absolutely. So given that it's in preview, it may be a bit more susceptible to, unexpected behaviors or errors. So, proceed with a bit of caution. OpenAI themselves, they actually explicitly advise against using it in environments where you have, full authentication enabled or for tasks that have really high stakes. And they also really emphasize the importance of adhering to their usage policies and their business terms when you're experimenting with this tool. So, treat it as a very powerful experimental feature that needs to be handled with care.
Yeah, I think that's good advice. Proceed with caution. So, how does this computer use tool actually work? Is it, directly accessing my operating system? Or how does that interaction actually take place?
No, it doesn't directly access your operating system in any, uncontrolled way. The way it works is through a very carefully designed feedback loop. So your code, it initiates the process by sending simulated computer actions to the model. Because it could be things like click X, Y to simulate a click at a specific point on the screen, or type text to, enter some text. And the model, it processes these actions, and then it suggests the next action that it believes will help to achieve whatever goal you've given it. And then your code takes that suggested action and executes it within a controlled computer or browser environment. And this is really crucial. After each action, your code has to capture a screenshot of the resulting state of the interface and send that back to the model. So the model is essentially seeing what happens after each action, and it uses that visual feedback to understand the current state of the interface and then determine the next action. So, in a way, it's kind of mimicking how a human would look at a screen and then decide what to do next.
That's a really clever approach, using that visual feedback to guide the next action. Now, in the documentation, they talk about setting up a local browsing environment. And they mention tools like Playwright or Selenium. And then they also talk about and the option of using a local virtual machine with Docker. What's the reasoning behind those specific technologies?
So those tools that you mentioned, Playwright, Selenium, those are very popular, very powerful browser automation frameworks. And they give you the level of programmatic control over a web browser that you need for this. So they provide APIs that let you do things like clicking buttons, typing into fields, scrolling through pages. And critically, for this tool, they allow you to capture screenshots of the browser window. Now, OpenAI really emphasizes the importance of using a sandbox environment for safety, when you're experimenting with this tool. So, with Playwright, for example, they recommend setting specific environment variables to isolate it, disable browser extensions, things like that. And then for an even more isolated setup, they actually provide a very detailed example of how to create a Docker file. And what this does is it sets up a complete Ubuntu virtual machine with a VNC server. So you get this really clean, self-contained environment where you can run the browser, execute those actions, and it really minimizes any potential risks to your local system.
Yeah, I looked at that Docker file, and it is quite detailed. I mean, setting up a whole virtual desktop environment.
It is, but I think that level of isolation, it's really a key safety measure when you're allowing an AI to potentially interact with, user interfaces. And then, once you have that environment set up, the documentation provides some really nice code snippets, in JavaScript and Python, showing how to use these automation tools to actually execute those actions that the model suggests, and then capture the subsequent screenshots within these very carefully controlled environments.
Okay, so let's say I've got my environment set up. I've got Playwright configured, or maybe I've got my Docker container running. What's the actual step-by-step process of interacting with this computer-using agent model?
Yeah, so the interaction follows a pretty clear sequence. So the first thing you do is you send an initial request to the computer use preview model. And you specifically tell it that you want to use that computer use preview tool. And along with your initial prompt, describing the task that you want the model to perform, you also need to provide some details about the display size of your virtual environment, and you need to specify the environment type. Is it a browser? Is it, Ubuntu? And then you also have the option of including an initial screenshot of the starting state of the interface. Now, one really important thing to note here is that for this tool to work correctly, you have to set the truncation parameter in your request to auto.
Right, I noticed that in the code example.
Yeah.
So I send that initial request off. What kind of response do I get back from the model?
So the response that you get back, it may include a computer call item. And this is where the magic happens. So that computer call item, it contains a specific action that the model is suggesting. So for example, it might say, click at these X and Y coordinates, or scroll down the page, or type this text into that field. And the response might also include, regular text output, or maybe requests to use some of the other tools. Now, these computer call items, they have a very specific structure. They specify the action type and any parameters that are needed. So, for a click, it would be the X and Y coordinates. And the documentation also mentions these, what they call reasoning items, which the model might include to explain its reasoning behind suggesting a particular action. It's actually really important to include these reasoning items in your subsequent requests to help the model maintain context.
Okay, so I get this computer call item back. What do I actually do with it?
That's where your automation code comes in. So you need to take that action that's described in the computer call and translate it into the corresponding action within your chosen environment. So, if you're using Playwright, you'd use Playwright's functions to perform that click or that type or that scroll action. If you're in the Docker environment, you might use a command line tool like xtool. And once your code has executed that action, the really crucial next step is to capture a screenshot of the updated state of the interface.
And then I send that new screenshot back to the model, and the loop continues.
Exactly. So you take that newly captured screenshot, you encode it, typically as a base 64 string, so it can be easily transmitted, and then you send that back to the model in a new responses.create request. And you send it back as this, what they call a computer call output. And it's also really important to include the call it from the previous computer call in this new request. So the model can really keep track of, the context of the interaction. And then this back and forth, it continues until the model either stops suggesting those computer call items, indicating that it's either, completed the task that you gave it, or maybe it needs further instructions, or maybe some clarification. And the documentation, it actually provides some really helpful code snippets that demonstrate this whole interactive loop. So it's worth taking a look at those.
This is really fascinating stuff. But I'm also thinking, this carries a lot of responsibility. I mean, we're essentially allowing an AI to interact with a computer interface.
Yep. You're absolutely right. And the documentation, it addresses this. They acknowledge that there are inherent risks involved. And to mitigate these risks, they've implemented these safety checks within the API itself. So, they have mechanisms to detect potentially harmful instructions. Maybe the model is trying to do something that it shouldn't be doing. And they also have checks to make sure that the model isn't interacting with, irrelevant or sensitive domains within those URLs that it's visiting. And if any of these safety checks are triggered during the model's, reasoning process, the API will actually return this thing called pending safety checks in the response that it sends back to you.
Okay, so what do I do if I get this pending safety checks back in the response? Do I just, proceed anyway? Or what's the recommended course of action there?
No, absolutely not. You should not just proceed. The documentation is very clear about this. If you get these pending safety checks, you have to acknowledge them in your next request. You use this acknowledge safety checks parameter to say, yes, I've seen these. But more importantly, whenever these safety checks are flagged, it's really strongly recommended to involve a human in the loop. A human needs to actually look at the action that the model is proposing and confirm that it aligns with the intended behavior, that it doesn't pose any risks, and only then should the process be allowed to continue. And they even suggest, for interactions with sensitive domains, this watch mode, where you have a human user actually monitoring the AI's activity in real time. And they also emphasize that it's really helpful to send the current URL of the browser with each, computer cal output, because that additional context actually helps them to improve the accuracy and the effectiveness of those safety checks.
Okay, so human oversight is really key here. Now, the documentation also mentions some specific limitations of the computer use preview model itself.
Right.
What are some of the things that we should keep in mind, regarding its current capabilities?
So right now, the model is really optimized and recommended for tasks that are primarily browser-based. Its performance and its reliability might be less consistent in other types of desktop environments. And it also has some, constraints in terms of rate limits and the set of features that it supports compared to, some of their more mature models. And another important point is that right now, the computer use preview model, it doesn't support zero data retention. So, that's something to be aware of. And for the most up-to-date information on the model's capabilities and its limitations, and those safety considerations, it's always a good idea to refer back to their system card, which they keep updated.
And in terms of just general best practices, for mitigating risks and ensuring safety when we're using this computer use tool, what would you recommend?
Yeah, so they offer a whole bunch of recommendations in the documentation. But, I think the key takeaways are, for any high-stakes tasks, you absolutely want to have a human in the loop, for verification, for approval. Be very aware of the risk of prompt injections. This is where the AI might inadvertently follow instructions that are embedded within content on the screen. So, using those trusted and isolated environments is really crucial. And they also advise, maybe implementing block lists or allow lists for websites or for actions, to really constrain the AI's behavior. And sending those end-user IDs with your requests can also help them with abuse monitoring. And then, of course, actively using and responding to those safety checks that the API provides.
Well, I think we've done a really thorough deep dive here into this computer use tool, from its underlying mechanisms to those really important safety considerations. It's clear that it's incredibly powerful, but it really does require a very thoughtful and responsible approach.
Absolutely. And what's so exciting is that this capability, along with those other built-in tools and enhanced state management, it really highlights where OpenAI is going with this responses API. They're really enabling us to create much more sophisticated, much more interactive AI applications.
So for our listeners out there, I hope this deep dive has given you a much clearer understanding of the differences between the, sort of more familiar chat completions API and this newer, more powerful responses API, and especially this groundbreaking, computer use feature. I mean, this is really changing the game in terms of how we can leverage the power of these large language models.
No question about it. And I think, understanding these nuances, understanding the potential of tools like computer use, while also, being aware of their limitations and the importance of safety, it really gives you a powerful foundation, as you go on to explore and build with these incredible AI technologies.
And on that note, here's a final thought to leave you with. As these models become even more capable of interacting with and manipulating our digital world through tools like the ones we've talked about today, What kind of fundamental shifts might we see in how we approach automation, problem solving, even, our daily interactions with technology? It's a really big question. And we encourage you to keep exploring, dig into that documentation and see where it leads you. So thanks for joining us for another deep dive. We'll see you next time.